Well, hello. My name is Leo Vasiliou, and I want to extend a healthy, sincere, good day to all of you. Thank you so much for giving us some of your precious time, and thank you for not harping on the misnomer moniker of the name of this track. That is, when we usually talk about performance, we don't usually talk about the number of nines as if we were talking about availability. And so that begs the question, what is the essence of this session? What's to remember long after this session is over? Well, very simply, I kindly suggest that performance is no longer just the cherry on top of your cake of availability. Rather, performance is your entire cake, right? You can't tell how fast or slow something is if it's not available in the first place. But as is the case with my usual say the last thing first approach, in order to appreciate that punchline, you have to hear the entire joke. And so, talking through this, you have a query on Google, which is what I refer to as an experience based full page load. Experience based simply meaning it contains a lot of components coming together to deliver an experience. And let's say, for the sake of the conversation, there's a service level objective of 99.9%. In this case, the service level indicator would be availability. That is the fraction of time the service is usable. And with that SLO, you have an inherent error budget of 0.1%. Now, as we said, that full page is comprised of a lot of components, right? The full page is presented via a web server, let's just say also with an SLO of 3 nines, a database server, also with an SLO of 3 nines. See some ads there, and let's just say that's managed by a different team, and their SLO is also 3 nines. And even though you can't see it, I'm authenticated. And let's say that directory service also has an SLO of, you guessed it, 3 nines. Now, the critical thought here is if each one of those components, the web, DB, ad, authentication, all have 3 nines for an objective, then Google.com's SLO should really only be 99.6%, not 99.9%, right? Because if each one of those components' error budgets are exhausted at different points in time, their cumulative effect on the total page load is the context we're talking about here. And that's what we mean when we say the number of nines depends on accumulation. Now, Alex and the wonderful team of speakers during SLOconf have done an amazing job of speaking to the components of availability indicators, objectives, and error budgets. And all I want to say here when talking about setting your cumulative based service level objectives is go easy on yourself. As Alex eloquently articulated in one of his previous talks, which is where this slide is from, we are all more tolerable to the little blips and hiccups than you think. And so now, team, if I could ask you, clap your hands, do a jumping jack, right? Some type of mental activator to indicate a section change. What we're looking at here is a consideration of a set of performance-based data, right? So we've gone from availability to now performance data as shown in the scatter. And in this case, we're looking at the various performance response times as measured from a CDN request. Now, we might say, what's my average response time? In this case, we apply the arithmetic mean average. We might say, our average is around 700 milliseconds, right? A little bit of fluctuation there. Or we might choose a median calculation, in which case we'd say the median response time is around 500 milliseconds. Median, or the 50th percentile, meaning that half of the performance data are equal to or below 500 milliseconds, and half are equal to or above 500 milliseconds. We may even continue to then go on to say, well, what about my 75th percentile? In which case we'd maybe say my 75th percentile is around 850 milliseconds, right? So 75% of my performance are equal to or less than 850 milliseconds. but 25% of my performance are equal to or greater than 850 milliseconds. And if we just show one more, just to kind of get where we're going here, we may go on to say, well, what's my 95th percentile? And as you can see, there's quite a jump. We might say, well, my 95th percentile is around 1800 milliseconds. That is, 95% of my performance are equal to or below 1800 milliseconds, but 5% of my performance are equal to or above my 95th percentile. Hold that thought while we jump and change visuals for just a moment here, because the reason our teammates run those different percentile calculations is to try and answer the question of, at what point does my performance data become abnormal or outside of my performance SLO? In which case, one might transition to this frequency histogram visual, which attempts to show the entire performance distribution versus a central tendency calculation. And we can see that the majority of our performance fall within the 318 millisecond to 402 millisecond range. But the two questions we're trying to answer are still not answered with this visual, or at least not answered very easily. And those two questions are, at what point does my performance data become abnormal? And more importantly, how do I use this to tell whether or not I've met my performance service level objective? And to take it a step further, remember when I was saying that this was performance data from CDN? Well, here are the histograms of only two of the many hundreds, if not thousands, of CDN pop locations. And if you stare at this long enough, you can kind of see that city B is a little slower than city A. We might say to ourselves, hey, let's put them in the same viewport like this, but still comparing the sets is a little clunky, and the two questions are still previously unanswered, right? Again, those two questions being, at what point does my performance data become abnormal, and how in the heck do I use this to tell whether my performance SLO have been met? And I guess what we've done here is we've added a third question. How do I compare whether performance SLO are being met across my various dimensions? In this case, CDN pop locations by city, but the dimensions could easily be parts of your application compared to other parts of your application, as just an example. Going back now to the previous time-based chart showing the different calculations and keeping in mind those unanswerable questions, I'd like to now introduce and discuss the cumulative distribution function, or the CDF. This may be a new concept to many, so let me just say that this is arguably one of the most powerful, if not the most powerful, performance analytics at your disposal. And basically what it does is put all of the percentiles across an axis, making it easy for you to spot the taper point, right? The hockey stick chart, if you will. In other words, it answers the previously unanswerable question, at what point does my performance data become abnormal? We can see that that taper point is right around that 93rd to 95th percentile. And to the other question about how do I use this performance data to know whether or not my performance SLOs are being met, this CDF definitively allows you to manage to your performance-based SLO. And we'll use the simple hypothetical example of, say, your target is 90% of my performance has to be 1,000 milliseconds or less. Well, we can very clearly see that 90% of our performance is equal to or less than 885 milliseconds. But before we get too excited, recall how I said this was performance data containing various dimensions, in this case, different CDN pops. Well, if we consider that hypothetical SLO of 90% of my performance data equal to or less than 1,000 milliseconds, we can see a very small percentage of data is not meeting our objective. And we can now focus our efforts on that specific subset instead of having to waste time where it's not needed. In other words, with this comparison ability, we would not be able to manage our performance SLO across these various dimensions. Now, I love the CDF. It gives us new abilities to manage our performance-based SLOs. It allows us to answer previously unanswerable question of at what point does my performance data become abnormal? And it provides a previously unavailable dimensional comparison ability for us to allow the matching of our performance from a service perspective to the multiple personality and dimension profiles of the clients who consume our services. Thank you so very much, everybody, and enjoy the rest of your talks.